So this summer we found this amazing bandsaw in a state of disuse. The odds of finding a giant Italian bandsaw in a backwoods town 8,000 kilometers from Italy is like finding a tree with no knots. This tool is significant for us because it represents our ticket into the interesting and somewhat flooded guitar top market. Large vertical bandsaws offer a higher degree of control than horizontal bandsaw mills, and old cast machines like this one remain the industry standard for tonewood suppliers even today. So after dusting it off, we managed to move the substantial tool to our off-grid workshop and started going through it. The main hurdle for us is likely going to be the power source, as our entire mill is run off of a small hydroelectric plant that doesn't like large single-phase electric motors, which this machine definitely has. And although it's kind of funny where the start switch is currently located, I think it might get old quickly. So that's going to have to move. And this whole shaft bolted to a board thing, that seems pretty sketchy, even for me. So I think this video, we're gonna redesign the drive system to better work on our homemade power and make it so starting and stopping the bandsaw doesn't involve reaching your hand through a moving belt.
We only have so much power here. Because we're off grid and we're using hydropower, we're limited to 20 kilowatts, but we can't use all of it because we're sharing that power.
Houses and us.
Whatever will run this thing and start, because startup uses 3 or 4 times as much power as running. Is it big enough, Sarah?
Yes. It's not going anywhere.
No.
Overall, this machine is in really good shape for its age. Other than a little rust on the table, which was an easy fix with some WD-40 and elbow grease, there was petrified belts and a broken brake. The brake is not crucial to the operation, it just is helpful in the event that you need to stop the thing relatively quickly. So because we didn't see anything too concerning going on here, we can start thinking about how we're going to power this machine.
Should we hook up a bike to it and we can have one person ride a bike while the other one cuts guitars?
See if you can get enough momentum.
My guess is that'll work just about as well as a chop saw powered by a spin bike. So I think we'll just leave that as a fun idea and move on to electric motors. So this is what I have on the shelf.
Yeah, all these ones are single horse right here. Basically 1 horse, maybe 2 horse motors. Not enough. You can just slap this thing on there, it would run. But that's only 1 horse, 1 phase, so.
Maybe we get 3 of those, stack them all up together. If we went 3-phase, and then we have a smaller motor that could fit in there.
What about the motor off the blower? The one that we just pitched out.
Yeah.
So that's 3-phase.
Yeah, 3 horsepower. Do you think that's enough, David?
Oh yeah. 3-phase, 3 horsepower, and that's at what, like 460 or something? So
yeah,
that's quite a bit of power.
The one thing we like about this motor is we're a bit familiar with it because it used to be our blower motor for our planer. And so we knew that we could turn this motor on and it wouldn't hit the power too hard. So that's a good thing.
Yeah,
so
go watch that video.
Yeah.
It'll be right here. Nothing gets wasted here. Everything is recycled.
We've really evolved. Now things don't even make it into our scrap.
Yeah.
Well, I'm still a little ways away from
it popping off. We'll skip to that. A lot of sawdust inside the electrical.
Yes. When I took it apart, I couldn't believe that we were running it like that. Because this thing used to get buried, right?
Yeah. A lot of guys on YouTube will just take a motor like that and do a full restoration video on just the motor. Unfortunately, we don't have time for that.
Imagine this motor, repainted.
Oh, mint condition.
Gloss.
Maybe with a little less sawdust in it.
Yeah, if we had time to take this plate off and pull the sawdust out.
Yeah, we don't even have time for that.
No.
Throw it in, get it working. We got to cut stuff.
How much do you guys think this motor weighs?
How many overhead presses can you do? That'll give me a good indication.
I don't think I could get it over my shoulders.
Crush this
appreciated. Oh my goodness!
Those are some serious plates right there.
Yeah.
Okay. Access to the brake. This is our brake lever, which is pretty bent.
As we both look at it and go,
But like, what does it do?
because that arm is bent, it should go all the way down.
Yeah.
As it turns,
Pushes
it's almost like a
out.
bolt turns out.
Yeah. Okay, that's the brake.
So yeah, it's probably all the noise.
Do you think it got dropped at some point in its life or something?
Oh boy. Did get dropped, hey?
It probably got dropped.
There's no cracks on this side. And it takes a lot of effort just to spin this thing.
That's the sound of bearings that need replacing.
Yeah.
Grindy.
Yeah. Doesn't
Good.
feel good, doesn't sound good.
Good news is that's a pillow block, so those are
Yeah.
pretty standard parts. We can get replacements, and also, do we even need them?
Yeah. That was a little too easy.
Yeah, pretty loose. It's a shaft.
Hello. I didn't know that came out.
So one benefit of using a three-phase motor is that the motor is smaller in size because there's more power available, so it doesn't need to be as big, less coils. We decided to mount the motor the same way that a table saw motor is mounted. Table saws usually hang the motor on a single fulcrum and allow the weight of the motor to kind of bounce on the belt, and that adds the tension to the system. This allows the motor to kind of clutch its way up to speed where the belt is slipping a little bit as it starts up. That means we're going to use less amps every time we start it up, which is good.
So some things have been happening around here. We've been busy.
You remember how earlier I mentioned that our power is off-grid, runs off microhydro? Well, that comes with sometimes some repairs and maintenance, and sometimes some big stuff that has to be dealt with immediately. In this case, a cracked pipe. This is all related content, but it deserves its own story, so following this I'll put up another video on it. For now, let's just leave it at.
We've been busy.
So in between all our other stuff we've been doing, we've been tinkering away on this. Probably the first thing that we did was we took off that old motor with its jack shaft. And one of the problems was the switch was mounted to the motor, and with the plywood cover over top, you actually had to reach through the belt to turn it on and off. So we pulled that all off. We found a motor. It runs at 3-phase 480. We don't want a huge initial draw. And so with running at a higher voltage, we'll have less draw for the same amount of horsepower. And so I did some research and I found that this is like a 27-inch bandsaw. 27-inch bandsaws are running about 3 horsepower if you buy a brand new one. So our motor is a 3 horsepower motor now. When this bandsaw was new, that's how the motor was originally orientated.
You can see the little bit of the motor just poking through there.
Yeah.
And then there is a pulley on the back side, which is roughly the same diameter as that mark there.
Yeah, it's about the same as that.
Roughly that.
Yeah.
And that's the drive pulley.
So this is what we had before. We had a 5-inch pulley going to a 9.5, and then going across its jack shaft to a 6-inch, and then over to a 13-inch. So we calculated out we were getting about 333 RPM. So now we just have a 2.75 going to our 13, and we're a touch slower now.
What does it say? 11% slower.
So instead of 333, we were at 296 RPM.
Right.
So once it's running, we'll see what the blade speed is like. You know, we'd like to have a significant amount of blade speed and we want to have the power because we're going to be putting full-size blocks through. We're going to be doing like 10-inch cuts all day long with this thing. So we want good blade speed and we want good power too. So, and then as a result of the fact that we bumped it up to 480 instead of 220, we had to find a new switch. We can't just use any old switch. So we've got this awesome box that we've repurposed. This was sitting in one of our sheds. Pretty cool to have this stuff just kicking around. So now from our motor, it comes up here. We got our 3-phase going into a magnetic switch. So this is pretty spiffy. And then we're gonna have to run our tech cable in from our power plant into here. And those wires are gonna come in the top here. And now we don't have to be behind the thing to turn it on and off.
Yeah.
Super cool key.
Yeah, that is a fun way to open a box.
I've taken everything apart here. All this stuff, all the guides have been taken apart and cleaned up and freed up. Everything's been oiled and cleaned. So we've got a whole bunch of different things going on. It's got these hardwood blocks. I don't know what this is. It's obviously quite hard, but it doesn't, you know, is it maple or something, or birch maybe?
It looks like maybe Purple Heart or something like that.
Yeah.
It's not purple
Pretty
anymore, but
porous wood.
mahogany.
So yeah, we'll see what those are like. And then one interesting thing this bandsaw has that I haven't really seen before is it's got a magnet.
Yeah.
So this top one here is a big magnet that runs along the side of the blade. And on the bottom, you got a magnet that runs on the other side of the blade. So there's a magnet going this way on the bottom side.
Okay. And then this is just a back catch right here. So the
Yeah.
back of the blade is supposed to hit right there. If
Yeah.
you're hitting that, it means you're probably pushing too hard or the blade is dull,
Yeah.
usually.
Yeah, things seem to be spinning pretty smoothly. And we did notice we've lost a wheel weight. So
Yeah, that's going to sit at the top, basically, if you spin it around and around.
yeah.
That it always ends up at the top. So that means that was a wheel weight at some point.
Yeah, and we cleaned up the deck. Kind of hard to tell now because I've been using it as a work surface.
Wow, there's no more rust on it, that's for sure.
No more rust. Yeah.
And then the other thing on our to-do list is the braking system, right? I see that the foot brake's not on
Brake
there
is
right now.
entirely removed. It's a little bit goofed. It was in pretty rough shape.
We might find that when we fire it up for the first time, it won't stop spinning.
It's got a lot of.
It just won't.
These wheels are so heavy when
Yeah.
you actually have them off. I had a really tough time getting this wheel back on because when you're crouched down, you just have no lifting power.
Cool. I'm
But yeah, we
impressed.
should wire this thing up. We should figure something out.
Yeah, we've got
this-
3-phase 480 right in that box.
Right in this box. Yeah, we've got some tech cable. Yeah.
As you can see, we've now turned the bandsaw about 90 degrees and we shuffled it into position off camera. It was slow and tedious work. And now we're just rigging it up to do a test run on the motor to make sure that the motor is gonna work for us. We drilled a hole in the back, very tight fit. Unwind a little bit more.
Yeah. Wiring with 480, you know, feels like something you're supposed to have like a degree to do.
Well, you're not wrong, Mike.
Yeah, it's like 220. I remember when I was first wiring with 220 and you're like, whoa, this is 220. I gotta be super careful. But now 220 just like, oh, it's only 220. 480, you have to have respect for 480.
I mean, you should all have respect for every amount of electricity. Even 12 volts is enough to hurt. Keep in mind, it's the amps that'll get you.
Yeah. Oh man, I almost set my riding lawnmower on fire and that was an eye-opener. You think like, 12 volts. Until you see like a wire just like burst into flame in front of you. Sort of a fun story actually is the coil is wired in reverse. It doesn't have a hot lead going to it. It only has a ground going to it. I put a new coil on. There's only one wire going to the coil, so I just wired my hot going to the coil. And as soon as I turned the motor on, the entire wire just had like the full current of the battery going through it because it was a ground. And yeah, like basically just like melted the wire and burst into flame in front of my eyes. Like it was like red hot, like an element. But it was going the whole length, all the way through your battery, down through the key and everything, and it's smoking and fire, and there's like nothing you can do about it. eye opening. We make a coil that only has a ground. I don't know.
This will not be like that scenario. Everything is very technically sound. There's no like loosey-goosey wiring here. Found some certainty in the diagram here. If this side is your motor, circles on wiring diagrams represent motors. That's always the case. We've got power being siphoned off of our main 460 to run the switch. So that's your switch, and the black lines are the power supply for it, and they run over there. So that means that your line 1 is on the left, 2 is in the middle, which Mike's working on right now, and 3 is on the right of that. It should have nothing connected to line 3, which is what the wiring diagram says. So yay for wiring diagrams. Without them, we would be lost.
Yeah.
All right, we've turned the power off. We found our 3-phase. Mike is currently working on unwinding tech cable, which if you haven't tried before, is not much fun. Or it's a very good workout. I mean, consider it how you will. So the hum of the transformers there. Switch is back on. Power is supplied into this box. We are a go for testing. Excited?
I don't know, I'm kind of nervous actually.
Yeah.
Okay.
Honors are all yours.
Oh my goodness! First time?
Is it spinning the right way?
It is spinning
Yeah.
the right way.
It's pulling down. That's good.
And you know what,
The lights didn't dim. That was good. Yeah. I can't tell. It might be slow. I have no idea. I don't know. We'll have to see by cutting something. It's definitely working. Let's check the motor. Overall, that's really quiet for a bandsaw. I'm pretty pleased with that, Mike. Good job.
I'm pumped.